Let's talk about the KKBOX case and feature engineering. So I'm going to load in the data set that we've decided to use for this case, which is about 100,000 different subscribers and split up so that about 20,000 churn and the remaining 80,000 don't churn. And our main goal is to figure out what the main drivers are for churning at KKBOX. Now, the data that's been provided to us is not that useful in the form that it currently is. There's not too many features that we can really study to see if they are drivers of churn. So what do I mean by that? Well, if I look at the churn data set, which is what's giving us the subscriber number, just an integer from 1 up to around 100,000, we have an idea for whether or not each user churned or not. That's in the is churn column. But there's very few characteristics of these subscribers that we can directly compare. So we might be interested in studying to see if the churn rates varied versus gender, and we could do that graphically with the mosaic command from reg class. So let me get that loaded in. And we could say, all right, well, let me visualize this relationship between is churn and gender. So putting in the churn data, we can look and we see that of the 3 levels of gender, the blank, the female, and male, we do see some differences. Male and female look to have about the same churn rates, but blank here has a noticeably smaller churn rate. So that potentially is one driver of churning, one characteristic that's associated with churning in the customers. And there's woefully few things actually in this data set that we can use. We could look to see, well, do churn rates vary from one city to another? We could look to see, is churn twiddle city? And just comparing the shaded regions devoted to red, we do see that, yeah, there is some variation in churn rates from city to city. If we wanted to clean up this visualization a little bit more, we could say equals true here, just so we could see a bar for each city a bit more clearly. And sure, there are some differences in churn rates as we consider cities to various cities here. But beyond comparing cities and their churn rates, the ages of people, their churn rates, how that's associated, genders, how they registered for the service, and something related to when they signed up for the service, there aren't any other properties of customers that are immediately available for us to see if they're main drivers of churn. And that's where feature engineering is going to come into play. So we actually need to construct features, basically characteristics about these subscribers that may be drivers of churn, and we can do that investigation to see if we're discovering anything worthwhile reporting. So what do I mean by that? Well, if I look at the all user data frame right here, remember what this all user data frame tells us is something about the complete listening history of each one of the subscribers in our data set. So if I wanted to look at, say, all of the listening history where MSNO equals to 1, I could take a subset and just peruse what I end up seeing. So in this case, we have a lot of different rows, but what's going on is we have an idea for what this subscriber was doing on each day where they actually listened to music. So this is the date marching forward in time. We have a pretty extensive listening history. Now, surely there's going to be some characteristics of listening histories that might be indicative of churn. So for instance, if we see the total amount of time that someone is spending streaming from KKBOX, we see that decreasing over time. Well, maybe that's an indicator of churn. Maybe that's one of the drivers of churn, the less and less engagement with the service over time. Or maybe it's the number of unique songs getting smaller and smaller over time, or something about the percentage complete that we have for various songs that have been listened to. And so here's where it's up to us to figure out, well, what do we want to measure about each one of these subscribers that might clue us in to their churn status. So for instance, I could say, well, let's go ahead and for each subscriber in the data set, let's count up the average or maybe the mean or median number of unique songs that they play throughout their listening history. Maybe that's something I would want to add in to the churn data set, an additional column that said, hey, here is typically how many songs they've listened to each day. Maybe we'll find that people that haven't listened to that many songs each day have a higher rate of churning, that the ones have listened to a lot more. And so how can we add this information to the churn data set? How do we do this feature engineering? So we're going to use the aggregate function pretty heavily along with merge to help us out. So what I'd like to do in this case is for each different subscriber in the all user data set, dive into that subscriber's value of, say, num unique and figure out what their average is. And we're going to add in that average as a new column in that churn data set. So with the aggregate command, the way that I'll construct that is I put on the left-hand side of the twiddle the column that contains the values that I'm going to use in my computation. On the right-hand side of the twiddle contains my grouping variable. So do this for each unique value of MSNO, each subscriber here. This lives in the all user data frame, and I just have to specify what I want to calculate for each one of these subscribers. What do I want to do with the values I see in the num unique column for each one of these users? And so in this case, maybe I want to look at the median. So I can say fun equals median here. And if I print that out to the screen, well, I'll get a huge old table of each subscriber and the median number of unique songs that they've had through all the days of their listening history. It's still a pretty big data set, so these commands are going to take a while to run, but it's just the price that we have to pay. We don't have that many characteristics of the customers to see what the drivers of churn are. We're going to have to create these characteristics, create these features based on their listening history and then also based on their transaction history. So this is taking a little while, but we've got it. And what we'd like to do is we'd like to add in this information into the churn data set. We want to add in a new column that lets us know what the median number of unique songs were. So here's what I'm going to do. I'm going to left arrow the result of running aggregates into some name I'll create. A is fine here. It's just going to be a placeholder. And this will allow you to work with the data frame that is created with aggregate. I'm going to go ahead and actually do some additional commands as this command is running. It's a long command. What I want to do is I want to add a little bit of clarity as to what was being measured beyond the default column headings that R is going to provide. So if I say names A bracket 2, that's going to allow me to change what is the second column of the data frame here, the name of the second column. So I want to be very specific and I want to say that this is the median unique songs. Somewhat informative, I know what that means. So if I go and look to see what this looks like here, we have median unique songs. And I essentially want to move this column over into the churn data set. So that's a job for merge. I'm going to take what the churn data set is now. I'm going to take information from the A data set that I just created. I'm going to match these two up with the MSNO. That's how we match one of these data frames to the other. And I'm going to say all.x equals to true. That way, all of the rows in churn are going to survive the merge. Now, they should all be matched up anyway, so this is more of a safeguard. And I'm going to overwrite churn with this merge. So that's fast, and what we have is a new column for the median unique songs. And so this is what I'd like you to do for the case for tie-in. I'd like for you to sit down and just look to see, all right, what information do we have about the transactional history of each customer? And what information do we have about the listening history for each customer? And come up with 3 or 4 different new features, something that we can summarize each customer by. So maybe it is something like the median total seconds per day over the listening history. Maybe it is the decrease, maybe the slope, if we were to look at a relationship between the number in the 25 column here and the date that we're considering. So you can just sit down and be creative about, okay, well, what might be something interesting and indicative of churn based on the information that's been collected for each user. And you'll run the aggregate function to measure that and then merge that column in to churn. So one more example here with the all trans. One thing we might be interested in looking at is, say, the most common payment method per user. So it stands to reason that maybe users kind of bounce around between what kind of payment method they're using. Maybe sometimes it's Bitcoin, sometimes it's credit card, sometimes it's gift card. And so we're going to use the aggregate function to summarize that. Let's figure out the most common method of payment here. So payment method ID twiddle, MSNO, Data frame is the all trans noun. And we just have to figure out, well, what function are we going to use? So I need the most common value if I were to consider all the numbers in the payment method ID column. This is going to give me a chance to write my own function here. And just to illustrate, let me just go and create a vector where I know what the answer is going to be. A whole bunch of 3's, but a bunch of different values here. So that's my vector. How do I get the most common value out? Well, here's a trick. If I do table, that gives me a frequency table. So here are all the unique values that I see and the number of times that they appeared. I can sort that table. It'll sort from smallest up to largest. And so if I want the most common, I can just do tail, comma 1. So we had 3 being the most common elements in this vector. It appeared 7 times. I just want to know, well, what was the name of this most commonly appearing category? I can extract out the names assigned to each frequency with the names command. And so this is essentially the function that I want to use on the collection of payment method IDs for each of these users. So how do I do a custom function in aggregate? Well, all I need to do is change what this function is. So instead of just using a built-in function, I'm going to say function x, and then I'm just going to copy and paste that here. So now we're explicitly saying, hey, go in for each subscriber number, extract out those values in the payment method ID column. What are we going to do with it? Well, we're going to make a frequency table, sort it, take the last element, extract the name. That's going to be the name of the most commonly occurring payment method for that subscriber. So we set it loose, we wait a little while. I'm going to go ahead and rename the second column here. So this would be the most common pay method. And then I'm just going to kind of borrow this. I'm going to take these two commands once again. I'm going to take what my churn currently is. I'm going to merge the information provided in A by subscriber number, match those up, and I'll make sure that I don't drop any rows of churn. So A is there. Let's change that name. Let's just take a look at it. So most common payment methods for each subscriber. Let's merge that in. And so now we have 2 new features. All right, are these useful features? Well, let's get a little glimpse of this. Let's see if there's much of a relationship between is churn and these 2 new features that we've created. So a few different ways of doing that. We can use plot is churn twiddle, and then whatever feature we've just created here, median unique songs, that lives in the churn data frame. In R, we'll figure out how to make a plot. Might not be the prettiest looking plot, but as we go to larger and larger numbers of unique songs, well, we don't actually see too much of a variation in churn rate. Maybe this isn't a major driver, but it was worth creating and examining. Another way to do it is with that mosaic command. Now, what mosaic will do, though, is it'll provide kind of a bar for each unique value in median unique songs. And as we can see, that's kind of a lot of bars. It's a little hard to tell what's going on here. So I would actually recommend plot for whenever that new variable you've created is numerical and has a lot of different values. We can save mosaic for those instances where the new feature you created doesn't have that many unique values, maybe as a categorical variable. So most common pay method, spell it right. And we see a pretty large variation in these churn rates. So most common payment method looks like it'll be one of these major drivers. So put on your creativity hats, play around with this, try to come up with something that maybe no one else in the class would think of in terms of what we can measure about the listening histories or the transactional histories that we can potentially use as a driver to detect churn. So look at those transaction data sets, look at the listening history data sets, get creative, come up with something that we could measure that could be indicative of very churny behavior. And then once you've done that a few times, well, the way you're going to submit this is you're going to save the churn file that you've created. So with the additional columns, you're just going to do save churn file equals my churn, let's call it, our data. You'll save that. It'll go into whatever working directory you're in, and you'll upload it. And we'll pull together all 60 student suggestions on Sunday by 7 p.m. So make sure to have that submitted by then. And we'll see where this takes us. We'll see if we can identify some major drivers.